Hey guys, how are you? Welcome back to our training. Let's talk about Windows binaries. This is gonna be our first important theory slides. Remember, this is gonna be more like giving you the foundations so that you can have good understanding of theory, and then we jump into the lab, right? Okay, so Windows binaries. We're gonna be running, as you know, a malware on this Windows operating system. So we need to learn how the executables are and everything. You know who I am. I'm not gonna repeat this. And we're gonna be talking about the building executables, how an executable in Windows is actually created, what is the format, how this is being loaded in memory. When you double click on something and then you just see the program being displayed in the screen. So what is the process behind it? That's very, very important for you to understand in terms of analyzing malware. And then we're going to be talking about the same thing, but with .NET binaries, which is actually called assemblies. Those are not called executables, and both are formats created by Windows. Okay, let's jump into the first one, which is building executables. So we're going to be talking a little bit about the process. The intention is not for you to understand what is a compiler, for example. I mean, just understanding a compiler is just a huge, huge effort that you need to understand. It's actually very complex. So I'm just going to give you the basics, right? So everything starts with a source file, which is a source code of your program. Like in this case, like a C++ program, for example, can be, depending on the programming language, like in this case, a C++, you have the source code, you have an editor where you're going to be coding your file. Then you have a make file. The make file actually has all the instructions needed to compile, meaning to create from source to a final executable file. But that goes into different steps. First one is preprocessor. Preprocessor is like specific instructions that you're gonna give to the compiler so that at compile time you can take decisions like, for example, if this is a Linux system, add a specific structure or a specific function. Or another typical example, if this is a 64-bit architecture, or 32-bit architecture, add these specific functions. Sometimes for compatibility issues, you do those checks, and those are being done at the preprocessor with those if def and if instructions, or if and def, which means if not defined or if defined questions. Then you reach the compiler, which in the next slide you're going to see more into the detail. But basically, this guy is going to go and get all the parsing of the source code and then create what is called object files. And these object files is actually machine code with linker directives, which are instructions for our next guy, which is the linker. The linker is going to take all those small pieces of objects, and eventually with those objects and libraries is going to finally create the final executable file. By the way, I missed to talk to you about the header file at the beginning. This is also external macros, or think about it like external references to your files, so that you can add more functionality, right? Like if you want to add a function that do some sort of a socket connectivity, you're going to add a header file which adds the header of the socket implementation, and that way you tell your program which other external functions you're going to be using. Okay, at the end you can have a debug version or release version, which it depends on you, but debugging version has like a more information about your binary, and the release version is more clean. Let's put it that way at this point. Okay, great. And you have the reference below. Okay, let's see more into the examples. And let's go into the compiler. Here at the top right, you see the whole 3 steps: compiler, object file, and linker, so that you don't get lost. So now, in the compiler phase, as I said, you have the source code. This source code has a lot of internal engines, guys. You have a lexical analyzer, you have a syntax and semantic analyzer, and you have an intermediate code generator. But basically, this whole thing means that every single line is going to be parsed by the compiler, and it's going to understand what that means. For example, those can be tokens, which a token is something like, for the compiler, it can have identifiers, like an X, color, up. This is some specific names that are only used by the compiler. Those are not treated as letters or strings, like a normal X. For example, a up can be like a instructions to move up into a specific functionality, right? It's not something like it's just a string. A keyword is like these are like decision instructions, like commands, like a if, while, and return. Those are normal instructions in the code that you can tell to do certain decisions. Or separators. Separators, sorry for that. So the compiler can say, okay, you know what, this is a curly bracket, then I need to have a opening and closing brackets, because it's some block code. Or, depending on the language program, if you have a colon or semicolon, is the end of the line, or the end of the instruction. So it needs to treat those depending on their action and their purpose. Operators, like plus or less than or equal, those also are interpreted and used as expected. So if you have an plus sign, that means you need to have a first an operator in the left side, and then operator, and then another number in the right side. And as you can see, it starts getting very, very complex, right? So at the end, you have literals, you have comments, so all those things are being defined in the source code. Then the compiler needs to go and do this whole analysis, and then finally interpret it and give you a final code, which is the machine code at the end of the day. After the compiler, it's going to create the object file, and then eventually the linker. Okay, so we're in the compiler side. Let's go to the object file. So the object files, once the compiler do this magic, then it creates different object files. An object file can be, for example, something related to connectivity, network connectivity, like this WS232DLL is for Windows network connectivity. And then this guy has some functions like connect and receive, and those end in something called symbol table. We're going to see in a second what this symbol table means. And then the compiler can has also another object file, which is a kernel32, which is more related to dealing with files, create or delete files functions, which also ends up in the symbol table. So as you can see, the compiler can create different object files, and all of them are going to eventually be used by our linker guy. Okay, the symbol table that I was telling you is kind of similar to the tokens that I was describing you before, but this is more like a understanding function names and parameters, put it that way, so that you don't get too much confused. For example, this bar here, it tells this bar in this address is a type of function. Oh, it's a function, and the scope is external, meaning this is can be used externally. Okay, and you know what? This X, what is this X? A type. It's a double. It's a type of number. And you know what? The scope is a function parameter. Oh, great. This being used inside the function. Foo is another function name. Count is a type of integer. Sum is a double. I is an integer. So you can see how this being mapped in addresses, and all those different symbols are being used also by the compiler. Now, and by the linker. And now, all these symbols, when you do malware analysis, you eventually are going to be seeing, like, for example, here, obfuscator. Oh, this is a function that probably is related to obfuscate something, right? So what the attackers does is they remove symbol tables so that you can have a clue. You won't have a, like, for example, here, you won't have a obfuscator function name. Instead, you only will have like a function 20. So then you don't know what it is, and then you need to go deep into do the analysis to understand what it is doing, right? That's one of the malware tricks that they do to remove the symbol table so that you don't have a clue of what's going on inside the function. Linker guy. Now we're here, compiler, object file, and now we are in the linker guy. The linker guy is going to merge everything together and create the final executable. So it has two options. One is the static linking. Static linking means that it can get all those different external object files and create one single file, which is called statically linked. That means everything is in one single file. Normally, it's a really big one. That's good if you're gonna do like a portability stuff, because basically you don't need to get anything external. Everything is in one single file, and then you can port it to other systems. Dynamic linking, that's another case. Dynamic linking is called dynamic because basically what happens here is that the linker is gonna create an executable file, but all the libraries that this executable is going to be using, those are going to be resolved at runtime, meaning at the moment that the executable is running in the system, at that moment it's going to go and say, hey, you know what, I need this library to connect to a internet. Okay, so let's go and load this DLL from from the file system into memory and use it. Oh, you know what? Also, I need another library for opening files. Oh, great. I load another DLL and call any function that I need from that DLL. So all those libraries are being loaded at runtime. That's why it's called dynamic linking, okay? And obviously, if you do one change in those DLLs, right away you can get the change in everything, right? You don't need to go in every single file like in the first case to do the changes. As long as you do one change in one DLL, it just populates in all of them, because every single file loads the same DLL multiple times. You know, one DLL can be loaded multiple times for multiple programs. At the same time, if you have a mistake, that mistake can also be one shot of damage across your system. One single fail, that same DLL is going to affect many executables that are using it. Okay, then finally, the linker, as I said, it can create at the end libraries, which is like a can be a statically linked, which is everything in one file. DLLs, which are executables, but these DLLs are, you're gonna see it more into the details in the labs eventually, but a DLL is like a library that you can use dynamically linked in Windows, but this library cannot be run by itself. It will always needs to be loaded by an executable. And you can also create executables. So if you have an executable, it can run by itself, and then this guy can run DLLs, and then also these libraries can be loaded into some programs.